Arctic is a hostile environment with its long periods of darkness and unfavorable weather conditions. But despite the cold, it is a hotspot for scientific research in which space plays a role. The Arctic is the region of our planet from a latitude of about 66 degrees north and above. Very few humans live in this landscape of snow and ice, but it's an area to pay attention to as it's undergoing some major changes. Considering the extreme cold and long periods of darkness in the winter months, following these changes is not easy from the ground. But some 800 kilometers above our heads, satellites can monitor what's happening across the globe, including the polar regions. And what they see is shocking. Glaciers melting and flowing at accelerated rates. And breaking up into massive icebergs. Permafrost thawing over time, releasing methane into the atmosphere. Ice loss from the ice sheet blanketing Greenland. And the sea ice that blankets the Arctic Ocean is diminishing over time. These are all direct effects of rising global temperatures driven by human-made emissions.
This is an area that it's undergoing a huge, dramatic change, and it's, as we know, not for the better. And it's an area that needs protecting very quickly. And even though you don't live here, what we're doing many, many kilometers away is influencing what's happening here. And if this disappears, we're all going to suffer from it in the future.
How would we suffer from something happening so far away? When land ice melts, it injects an increased amount of fresh water into the oceans. This is making the sea levels rise worldwide, putting coastal communities at risk, but is also changing ocean salinity. This directly influences ocean currents, and therefore, the way heat is transported across the globe. In addition, melting permafrost is releasing increased amounts of methane into our atmosphere. As a strong greenhouse gas, this is further exacerbating the rise in global air temperature.
We talk about the impact of melting snow and ice surfaces in terms of what's known as the albedo effect. When snow is dry, it's very reflective, and of course that helps to reflect sunlight back out into space, and the consequence is we can reduce the amount of melting this way. However, as ice and snow melt, the albedo and the reflectivity becomes lower, and this has the effect of absorbing more of the solar energy. This contributes to further warming and further melting.
Satellites are helping to monitor and measure many of these changes happening in the Arctic and can help predict their consequences. But long before gathering this information is even possible, instruments need to be designed, developed, and rigorously tested before going into space. Taking off from Longyearbyen, one of the most northern cities in the world, these scientists are testing a microwave radiometer for a future satellite mission to study sea ice.
We measure the electromagnetic radiation that the sea ice emits.
And what can we derive from this?
Through that you can derive density and thickness and so on.
The scientists have to brave freezing temperatures and long flights out over the Arctic Ocean to advance the technology used to monitor this environment. But they know it's worth it.
What's your favorite part of these sorts of campaigns?
Well, to be honest with you, my favorite part is the Arctic environment, the nature. Seeing the absolutely amazing view here and being able to contribute to the sort of well-being of this amazing environment is absolutely amazing.
Some of the polar orbiting satellites that are monitoring this delicate environment send their data down to the Svalbard Satellite Station, also located in the Arctic.
All the data from these satellites are very important for a lot of people around the world when it comes to the weather, the health, the future of the planet, of course. So it's really nice to be part of that and to help people get this information and distribute it.
Research in the Arctic, from the ground to space, provides scientific data on the status of this delicate environment on which policymakers can base their decisions. Without this unbiased information, we wouldn't be aware of the far-reaching effects of climate change.
We need to protect our planet. Our Earth observation missions are extremely important because they really are they're observing where we live. There's still so much to be learned from our Earth and our environment, and there's still so much that we still don't know.
For more information on ESA's activities in the polar regions, you can visit our website at www.esa.int.